we established the governing differential equation, and then we solved for the governing differential equation, and we found the roots of the governing differential equation, and we discussed these roots for the governing differential equation depending upon the damping ratio. And we identified three types of system: overdamped, underdamped, and critically damped. And we plotted the graphs and we superimposed the response, and we found the salient characteristics of the various types of system. So, and we have solved this several numericals on this, and so let's continue with this. So, the last numerical on damped system, that is viscously damped system. Okay, so let me read the. A viscously damped system has a stiffness of 500 Newton per meter. Critical damping coefficient is 0.2 and logarithmic decrement is 2. If the initial velocity of the system is 1 meter per second, determine maximum displacement of the mass and amplitude after 2 cycles. Okay? So these are the questions. Data I have summarized over here. K is equal to 5,000 Newton per meter. Cc is equal to point, that is critical damping coefficient is 0.2 Newton second per meter, and logarithmic decrement is 2. Okay, this diagram will not be given. You have to construct this on your own. Okay, so based on this, whatever data is given, open up the quiz link and answer this quiz question. Alright, do not submit the quiz. You have to submit the quiz at the end of the lecture. So, system described in the question, it is asked, is it, what type of system is this? Okay, so various options are given. And are you able to access the form? The quiz form, are you able to access it? Hello.
Sir, 1 minute.
Yes, sir. It has been already sent on the group. It's accessible. Huh? Accessible. Huh? So that's first question. The question is displayed on the screen. Just select the appropriate option and then we can go to the actual solution. Done? Just take a snapshot so that I can start the actual solution. So the solution for this type of system is, we have already derived this, xt is, that is function of displacement as a function of time, is x e raised to minus zeta into omega nt cos omega dt minus phi. All right. So x at is equal to 0 is 0. Initial displacement is 0. So x cos of minus 5 is equal to 0. So x cannot be equal to 0. So only option is cos phi. The cos of minus 5 is cos phi. So cos phi is 0. So phi is pi by 5. All right. So that makes our equation x small x as function of time is capital X into e raised to minus zeta omega n into cos omega dt minus pi by 2. So xt is equal to x e raised to minus zeta omega nt sine omega d. Alright. So this is our equation for displacement. Okay. So in the question, it is asked maximum displacement of the mass, so that we can get it from this equation, and amplitude after 2 cycles. Right? So let's calculate one by one. So now differentiate this equation. So I differentiate this equation. So x dot t is equal to x e raised to minus zeta omega n t into minus zeta omega n sine omega dt plus x e raised to minus zeta omega nt cos omega dt into omega d. All right, so that's the derivation. And what is the initial displacement given? Oh, sorry, initial velocity, what is given?
So 1 meter per second.
1 meter per second.
So x dot at t is equal to 0, or I also write it as x 0 dot is 1 meters per second. Right? So substitute t is equal to 0 in this equation. So all that remains is this term becomes 0, this term becomes 1, this becomes 1. So only things that are remaining are x and omega t. All right. So what do I get? All right, I get x0 dot is equal to 1 is equal to x into omega t. Is that okay? All right, here, any questions you ask immediately. Okay. Now, critical damping coefficient CC is given as 200 newtons second per meter. That is equal to 2 into root k times m. M is equal to 2 kgs. Omega n is equal to square root of k by m. That is equal to 5000 divided by 2. So that comes out to be 50 radians per second. Okay. And damping logarithmic decrement is del. It is twice by zeta upon square root of 1 minus zeta square. So zeta is equal to del divided by 4 pi square plus del square. That is equal to 0.3. Okay. And damping frequency is omega d is omega n into square root of 1 minus theta square. This comes out to be 47.70 radians per second. Now you have this relationship x into omega d is equal to 1. So that gives you the displacement as 0.021. That is what is asked in the question. That is the maximum displacement. Okay. All right. Now you can answer this question. Damping ratio. Enter the value back. Huh? Yeah, just enter it in the quiz. Okay. Now again, let's go back to our equation for displacement. Xt is equal to x e raised to minus zeta omega and t sine omega d. If you have any questions, please ask. So I will just substitute all the values. So x into t is equal to capital X is we have just found out 0.021 into e raised to minus zeta is 0.3, omega n is 50 into t, and sine omega d is 47.7 into t. So that makes displacement xt is equal to 0.021 e raised to minus 15t sine 47.7. All right. So what we got, x is not the maximum displacement, it is the initial amplitude of the mass. So now differentiate this. and equate it to 0 and find the corresponding time. Okay, so what we have got is the value of x. All right, so now we have to find out x max. So how to find out x max? Yes, anybody?
Sir, when the velocity will be 0.
So velocity is derivative of x dot
X dot will be
t
0.
is equal to 0, right?
Yes.
So differentiate this equation and tell me the corresponding value of t. Who was the person who answered the question just now?
Manan,
Tap ID
59.
39.
59.
Huh?
59.
59. You can enter the value in the chat box also if you want. Okay. Has anybody got the answer for T? Hello, is anybody solving? Are you able to solve it? Okay, let me solve it. So differentiate this equation with respect to time. So I get
2 seconds.
0,
0.026.
0 to 6, correct. So T is 0.0265 seconds. Anybody else getting a different answer?
I'm getting 1.52.
No, that's anybody else?
Sir, I too got 1.52.
Anybody else getting any different answer? One other than 1.52. So who got 1.52?
Sir, I too got 1.521.
Manan,
Manan, you got 1.52. Anybody else?
Yes, sir, me too.
Snake, SAP ID 32.
30.
Name?
Dhruv.
Pro. Anybody else?
Sir, me too.
Huh?
Me too, sir. Arshal,
SAP ID?
36.
That's it. All right. So correct answer is t is equal to 0.0265. Okay. Just check your answer. Those who have got it 1.52. Alright, so correct answer is this. Alright, so substitute that value of t in the equation of displacement. So xt is equal to 0.021 e raised to minus 15t sine 47.7t. That is equal to 0.0265 seconds. Okay. So substitute that and that will give you the value of x max. So substitute and tell me the value of x max. I would prefer if somebody else other than Mannan, Dhruv and Harshal would answer the question for the and tell me the value of x max. So these students have already answered. So if just hold on, these three students just can hold on and let somebody else who is willing to answer, let him answer. Otherwise, you can answer. Yes, anybody else with the answer other than these three students?
Yes, sir. 1 second.
So 0.013.
0.013. Who is that?
So Hitanshu Shah.
Hitanshu, 0.013.
Yes, sir.
SAP ID?
56.
Sir, I am getting 0.00311.
Yes,
Who
sir.
is
Even
that?
I'm getting that.
Like there are 3 zeros after the point.
Yes, sir.
0.00 something.
Yes, sir. I am also getting the
Yes,
same.
sir. 3.11 into 10 raised to minus
Yeah,
4.
one by one, tell me the SAP ID.
Sir, I am getting 0.17.
Okay, SAP ID.
2.
Ayush Shah, set 21.
Ayusha, what is the answer?
Sir, 3.11 into 10 raised to minus 4.
Okay, SAP ID
21.
21. And 02 is who?
Arish Bandudekar.
Arish Vanade.
So 0.01.
So even I've got
I am getting
3.11 answer.
3.1110.
Yeah, one by one, tell me the name, SAP ID and answer.
Deepak
Sir,
27.
Ganesh
Sir,
Shah.
Deepak, SAP
One
ID
by one,
32.
one by one. Deepak,
27.
SAP ID
27.
27.
Yes.
Anyone else?
Sir,
Sir,
Deepak,
I am getting
3.1.
Name,
Kushal Shah,
SAP ID
46.
46. Anybody
Sir,
else?
Ganesh. Sir,
Sir, I am
Ganesh Shah.
getting 0.
Can it, how much? SAP ID
54. I'm
54.
getting 3.11 into 10 raised to minus 4.
Okay, anybody else getting any different answer?
Sir, Dev Panchal. Sir, tap ID 45.
44. Okay.
45. Sir.
Anybody
45.
else? 45? What is the answer?
0.00031. 3 times 0.
Okay, all right. All right. So I hope that's all. So the correct answer after I substitute t is equal to 0.0265 will give you x max and x max is 0.0134. So I think someone has got that answer. Okay.
Yes,
So then next you have to find the amplitude after 2 cycles. So to find the amplitude after 2 cycles, take del is equal to 2, number of cycles will become 2 and you have to find x1 by, right? So you have to, x1 is what? What is x1? Yes, can somebody tell me what will be x1 in this equation?
So it will be X max.
X max.
All right, tell me SAP ID who is saying that it should be X max.
Manan, 59.
Huh?
So there were two people.
Yes. 15. Manan again. It is 59. Anybody
Yes, sir.
who thinks it will be different value? Yes. Arish Bandevdekar. What will be X1?
Saturday's X max only.
X max. Okay, so it is X max obviously. So suppose, because suppose this cycle is starting like this, the first displacement is the maximum displacement, correct? So this is X max, right? And that is also equal to X1, right? And this is your X2, right? So X1 will be nothing but X max, that is 0.0134. So substitute and you'll get X2 as equal to 2.454 into 10 raised to minus 4 meters. Okay. So using that, answer the third question in the quiz and just follow the instructions. All right, done.
Yes, sir.
Okay. All right. So far we have seen viscous damping. Now let's move on and let's see what is Coulomb damping. Okay. So in the beginning of the lecture, I have just briefly introduced Coulomb damping. So does anybody remember what do you understand by Coulomb damping? What do you mean by viscous damping? Can somebody tell me? When do you say
Damping due to viscosity.
viscosity of a fluid? So okay. So when do you say something is damped by and that damping is Coulomb damping?
Due to friction.
Due to friction. Okay. So if the damping is due to friction, then damping is considered as a what you say as the Coulomb damping, and in this case the damping force Fd is nothing but your frictional force, that is nu into n. Alright, so that is the damping force. So let's consider a spring mass system, and this mass is oscillating about some mean position, and the displacement is x dot x double dot. So if the displacement is on the right hand side, then you have the normal reaction, and this will have the frictional force. Okay, so this is the general free body diagram. Okay, so I have just constructed that. So now let's first let's go back to this slide. So let's consider this system with no friction. Right? Let's consider this system with no friction. So there is no friction. There is mass. It is moving on a smooth surface. X dot x double dot is the displacement. Then this is the mean equilibrium position. And the mass is spring is stretched and the mass is moved to the right, and so mass is on RHS right hand side of mean equilibrium position. All right, and we have already solved this for this, and we have written the governing differential equation for such a mass, the governing differential equation using D'Alembert principle. So that becomes minus kx is equal to mx double dot. Okay, so that is the equation, and the mass oscillates about the mean equilibrium position. All right. Okay. Now there are some points that we should consider. All right. So the mass is performing simple harmonic motion. Okay. So it is moving from extreme left to extreme right, and from extreme right to extreme left. Okay. The governing differential equation for the entire motion remains same, whether it is on the right hand side of the mean equilibrium position or left hand side of the mean equilibrium position. Is it agreed? What is the governing differential equation for a spring mass system with no damping? Mx double dot plus kx is equal to 0. This is the governing differential equation for this entire motion. Okay, the mass will move from left to right and then from right to left. Move from one extreme position to other and then come back. That is for one oscillation. Is that okay? Hello, everybody agrees with that?
Yes,
Alright?
sir.
Yes.
Now add friction or frictional or damping force to the motion. Okay. Now when you are so first case when you are doing this, assume that the mass is placed at the extreme right hand side position of the mean equilibration and then the release from the rest. Okay. So these are some of the things we are going to consider while deriving the equation for the Coulomb damping. Okay. Now let's consider two cases. First case is mass moves from motion from right to left. Okay, moving from right to left. So this is the mean equilibrium position. The mass is on the RHS of the mean equilibrium position and it is moving from right to left. This is the spring force Kx. This is the normal reaction. And obviously, if the mass is moving from right to left, the friction is opposite. So this is the frictional force. All right. So our governing differential equation is what? Without friction, minus Kx is equal to mx double dot. All right.
MX double dot.
Mx double dot. And we are assuming that this is for when the everything in the direction of the motion is to be taken as positive. Okay. Now, if I add friction, then what happens to this equation?
So minus kx minus mu.
Plus mu n.
See, the
Friction will be acting opposite the motion. So it's minus.
so you see Kx is taken as minus Kx. All right. So friction is opposite to that. All right. So it will be, if this is taken as negative, then friction will be taken as, you have to add this. All right. So this will be plus F. Okay. See, I am just see what I am doing. Let me just explain what I am doing. I am not applying the sign convention to this spring force. I am using this as the governing differential equation, mx double dot plus kx is equal to 0. This is the governing differential equation, and I am rearranging the term, and I am writing minus kx plus is equal to mx double. Is equal to mx double double. All right. Now the friction is opposite to the spring force. If this is minus k taken as minus k, then I will take this as plus. All right. Just I am taking the opposite of them. So I can rearrange this term and I can write it as mx double dot plus kx minus f is equal to 0. Is everybody comfortable with the way I am writing the equation? Any questions? Hello?
Yes, sir.
No, sir.
हाँ तो कहाँ से? नहीं बाद में मैं किसी का. Hello. Okay, so is everybody comfortable with this equation? Any questions?
No, sir.
Oh, all right. So the mass is moving from right to left, and here I have, so I can write mx double dot plus k into x minus f by k is equal to 0. All right. See the conventions which we use for writing our general equations, where just to elaborate, when we are writing the governing differential equation, when we derived this equation, we took the motion x dot x double dot like that. All right. And this was the swing force kx. All right. And then we did, so the summation f is equal to ma, and right hand side forces were taken as positive, and left hand side forces were taken as negative. So this becomes minus kx is equal to mx double dot. All right. So what I am doing is I am using this. This equation remains same for throughout the motion. Okay. Only when the direction is reversed. Okay, the convention has to change now. All right. Is everybody clear with that? Okay, I hope that is clear. All right. So I can write this x minus f by k as y. So this equation becomes my double dot plus ky is equal to 0. All right. So this is the governing differential equation when the mass is moving from right to left. All right. Assuming that the position of the mass is on the right hand side of the mean equilibrium position. Okay. So what does this mean? When the mass is moving from right to left, the mass is performing simple harmonic motion about this axis x minus f by k. Okay, so we'll see about this. Now, what will be the boundary conditions for this when the mass is moving from right hand side to left hand side? Can somebody tell me?
Sir, the velocity at the extremes will be 0.
Okay.
And the displacement at the mean will be similar to this.
Displacement at the.
So if it's x minus f of k is the center line, then at the extremes it will be maximum displacement, and
So,
at the mean line.
X at t is equal to 0 will be what?
So maximum displacement.
X0. Okay. And what will be x dot at t is equal to 0? That is the
0.
0. Okay. So this becomes the boundary condition. Okay. So answer the next quiz questions. What are the boundary conditions for the above solution? Select the appropriate answer, and then we'll move to the next part. Any questions you have, you please ask. This is slightly volatile content.
Done, sir.
Oh, all right. So now let's move on to the next slide. Now let's plot the equation of the motion. So the particle initially that is at t is equal to 0 is at the extreme position x0, and now the motion SH simple harmonic motion is not about this axis. Okay, the axis is shifted to y is equal to 0. It is this motion is taking place about y is equal to 0, or in other words, y is nothing but x minus f by k is equal to 0, or it is taking place at x is equal to f by k. So this distance, x is on y axis, so this distance is f by k. All right, this frictional force upon the spring constant. So the one half of the cycle, the horizontal axis about which this SHM is taking place is this x is equal to f by k. All right. And the equation of the motion is given as y is equal to a1 cos omega nt plus b1 sin omega nt. That is based on your earlier result, because it is a simple harmonic motion. Okay. And y is nothing but x minus f by k. All right. All right. So what does this show? This mass performs simple harmonic motion when it moves from right hand side to LHS side about axis y is equal to 0, or x is equal to x minus f by k is equal to 0, or x is equal to f by k. Okay, so that is for one half of the cycle, these are the equations. Any questions regarding this? Is everything clear? Is first half of the cycle completely understood? Hello. Any, if you have any questions, please ask. Pardon? Which part? See, when simple harmonic motion is considered, generally, okay, if F by K is not there, if this frictional force is not there, then what is the axis about which this simple harmonic motion is will be happening at x is equal to 0? That is, when is x is equal to 0? On this horizontal time axis. Okay, but due to presence of friction, for one half of the cycle, the axis has now shifted to x is equal to F by K. So about this axis, this dotted line, this one half of the cycle is performing simple harmonic motion. It means this part and this part, these are equal. Got it?
Yes, sir. So, but so in this scenario, when we take the frictional force, so will it be static or kinetic?
Kinetic. How static? It will be kinetic because it is everything is moving. Okay. Now, so our equation is x is equal to a1 cos omega nt plus b1 sin omega nt plus f by k. Okay, so now apply the boundary conditions which we have first just discussed. X at t is equal to 0 is equal to x0 and x dot at t is equal to 0, that is the velocity is 0. Okay, so substitute that at t is equal to 0, so I get x0 minus f by k is equal to a1 and take the derivative. X dot is equal to a1 into omega n into minus sin omega nt. So first term is negative plus b1 into omega n into cos omega nt, and the derivative of this is 0. And this at t is equal to 0, this is equal to 0. All right. So that put t is equal to 0, so this term becomes 0 and this term becomes 1. So b into omega n is 0, so therefore b1 is equal to 0. All right. So substitute a1 and b1 in the equation, and I get x minus f by k is equal to x0 minus f by k into cos omega nt. This is valid for this time period. For 0 to, that is the one half of the cycle, this equation is valid. All right. Any questions? Okay. Now, using this, this equation, because now we have to solve for the next half, so we need to get the boundary conditions for the next half. Okay, so I will get that. So at t is equal to pi by omega n, what will be the displacement? So x, so substitute t is equal to pi by omega n. Hello. Huh? Oh. Huh. Oh. नाही दोन्ही एफ डिव्हिजनचे सेट म्हणजे नाही वेगवेगळे सेट आहे, वेगवेगळे सेट आहे. एक सेट 1 आहे 4 आहे ना, 4 तो सेट 1 आहे. फर्स्ट पेपरचा झाला 4, जो ब्लॉक 4 आहे ना, ते अपलोड करताना त्याच्यावरती तो ब्लॉकचा नंबर तो येतच नाही. अच्छा, मी एक आता ना माझं लेक्चर चालू आहे, मी लेक्चर संपल्यावर खाली येऊन तुम्हाला सांगू का? हा, मी कुठे खाली ते फर्स्ट फ्लोअरच्या स्टाफ रूम मध्ये असतो ना. हा, मी तिकडे येऊन सांगतो तुम्हाला, ते कन्फ्युजन नको. हा, ओके. All right, sorry about that. So substitute t is equal to pi by omega n is equal to x is equal to f by k minus sorry into x0 minus f by k into cos pi. And what is the value of cos pi? Minus
Minus
1,
one.
Minus
right? So x at t is equal to pi by omega n is equal to minus x0 minus 2f by k. Okay? This is a very important value. This will be the boundary condition, one of the boundary condition for second half of the cycle. Please keep this in mind. Okay. So also, what does this tell you? This equation tell you? Can somebody tell me how? What else do you interpret from this equation? What is happening to the mass after one half of the cycle?
So the amplitude is reducing.
Yes, amplitude is decreasing. And
By how much? By
friction force direction will change.
why?
So like
2 by k.
the
By 2f by k. Alright. So after one half of the cycle, the amplitude reduces by this value 2f by k. Alright. Okay. So I hope everything is clear about this first half of the cycle. This you have to keep in mind. You will need this when you solve for the second half. Now let's go for motion from left to right. Left to right. All right. And this is the mean equilibrium position. Again, I am considering the position of the mass when mass is on the right hand side of the mean equilibrium, but it is moving from left to right. Okay, so it is moving from left to right. So this is friction will be in opposite direction, and this is the normal reaction. Okay, spring force remains same in the same direction. Okay, now our governing differential equation is what? Minus kx is equal to mx double dot in absence of friction. Okay, now here friction and kx are aligned, so I will write here minus f instead of plus f because both are in same direction. All right, or I can write mx double dot plus kx plus f is equal to 0, or I can write mx double dot plus k into x plus f by k is equal to 0. All right, or x plus f by k is equal to y, or I can differentiate this and I can write my double dot plus ky is equal to 0. All right. So now can you interpret this part of this half of the cycle just like we interpreted the earlier? So what does this tell you? This value tell you?
Sir, the main line will be like below the mean position and by the
Correct.
fx.
Okay. So this shows. So who is that? Yes. Who is
Ayusha.
that? Who's
Ayusha.
SAP ID is
21.
21. Okay. All right. So what does this tell you? When y is equal to 0, x plus f by k is equal to 0. So x is equal to minus f by k. So that means what? This for the second half of the cycle, the SHM is performed about this axis. Okay. This axis, this distance is f by k, and it is negative. That is, it is minus f by k because it is below the horizontal axis. All right. So now this second half, the SHM will be balanced about this half. So this will go up, and this will be something like this. All right. So let's just draw this neatly. So this will be minus f by k, and this is the second half of the cycle. Okay. This is x0. This will be x2. Okay. Displacement is y is equal to a2 cos omega nt because it is SHM. Okay, this from here to here, it is t is equal to pi by omega n, that is half of the cycle, to t is equal to, so this half of the cycle is pi by omega n less than or equal to t, less than or equal to t, 2 pi by omega. All right.
So,
Huh?
so can we say that whenever the velocity attains zero, it will change its mean position line?
Yes, from one extreme position when it goes to another extreme position for the next half of the cycle, the what do you say, the axis about which the SHM is performed about that half will change. Yes, you can of course say that.
And so the amplitude of the one x1 minus x2 will be 4k 4f by k.
Correct. Correct. All right. So you have already gone to the part which I am going to derive. So that is good. But now can you tell me, so now we have to answer the next quiz question. What is the boundary condition for the second half? For solving, for finding out A1 and A2, now you need boundary conditions. So for that half, you need to tell me what are the boundary conditions. Okay.
At
So
t equals to pi omega.
yes, what are the boundary conditions?
So B of
So x naught will be equal to x at t equal to pi by omega will be equal to the last that we wrote, x minus 2f by 12
Is equal to
minus
minus
x bracket x naught
X naught, deck X naught
plus 2f of k,
minus
into
2f upon k.
K,
So
correct?
plus
Alright, that is the one boundary condition. And what is the second boundary condition?
velocity will be 0.
Velocity at x is equal to t by x dot, that is at t by pi by omega n is equal to 0. So that is the second boundary. So choose the appropriate boundary conditions from these 5 options, and you can submit the quiz. Okay, you can okay, submit the quiz at the end of the lecture. Otherwise, we'll okay. So omega n is the root of k by m, and y is equal to a2 cos omega nt plus b2 sine omega nt. Okay, the constants have to be changed. So x plus f by k is equal to a2 cos omega nt plus b2 sine omega n. Okay, so for pi by omega n is then equal to t pi by omega n. So substitute the two boundary conditions. Okay, one is that displacement, one is for the velocity, and you get, so for first boundary condition, x plus f by k is equal to a2 cos pi plus b2 sine pi. All right, so a2 is equal to x0 minus 3f by k, and x dot is equal to minus a2 omega n sine omega nt plus b2 into omega n cos omega nt is equal to 0 at t is equal to pi by omega n. Substitute that value into 0, and this will give you b2 is equal to 0. All right. So you got again a2 and b2. So now substitute the value of a2 and b2 in the equation. So this becomes x plus f by k is equal to x0 minus 3f by k into cos omega nt. Okay. Now you have to find the amplitude at the end of at the end of cycle. Okay. So amplitude at end of, so let's call this as x1. So x1 is equal to displacement x at t is equal to twice pi by omega n. So substitute t is equal to twice pi by omega n. So I get x1 plus f by k is equal to x0 minus 3f by k into cos of 2 pi, or I can get x1 is equal to x0 minus 4f by k, which somebody just now pointed out will be the what do you say, displacement or the amplitude after the end of one cycle. So after the end of one cycle, the displacement is sorry, the amplitude is reduced by 4k. And also f is equal to nu n, so I can write it in f is nu n. So I can write del, that is the decrement, is x0 minus x1 is 4f by Python. Okay? So how is this different from your logarithmic decrement?
Sir, for that the mean position is always fixed, and here the mean position is constantly changing.
Yes, in what do you say, damped system, the decrement doesn't remain constant from any two adjacent what do you say, adjacent peaks. Here the decrease is uniform. So if you join the peaks of the what is the cycle, you get a straight line. Okay, in that you will get a exponentially decaying line. Alright, so that is the difference. All right, any questions? Okay, so I have plotted this cycle for this Coulomb lamp system undergoing displacement in Coulomb lamp system. Any questions?
No, sir.
All right, so one more quiz you have to solve. Like a refresher, help you refresh your all your understanding. Okay, today the practical will be for both the batches. Huh? Because yesterday Python practical was done. So I'm sharing this second quiz that you have to solve on the chat box. Please open the form. And that's all for today. It's a true and false quiz. Everybody is able to access it.
Yes, sir. Detective.
So questions you have?
Sir, questions are not like
Questions. Okay, just a minute. Questions are on the slide. I've sent the questions. Okay, I have shared the question with the CR. Please post it on the group. अरे ये क्या है? Hello, has everybody received the question?
No, sir.
Is the CR there in the lecture? Hello.
Yes, sir.
Yes.
No, sir. Akshat is not in the.
CR is not there in the lecture.
No, sir.
क्वेश्चन से एडिशन नोट्स पे है.
Pardon? All right, we'll stop for today. What do you do? I will give the quiz in the next lecture. Okay, so don't worry about the quiz. We'll do it in the next lecture. Delete the quiz.
Yes, sir.
All right, any other questions you have before we end today's session?
No, sir.
All right, so let's end today's session and keep in mind both the batches will have the practicals today. I have already scheduled it. I hope all of you have received the message. Both the batches will have the practical today, A1 and A2, and we'll be doing the problem on trifilar suspension.
Sir,
Okay.
8 students will not be able to see that scheduled lecture.
I didn't get it.
Sir, 82 students will not be able to see that lecture because we are not there in that team.
No, I have scheduled it separately for A1 and A2.
No, sir, it's not there.
Both the teams have scheduled it. So both the teams have to join. Okay. So I'm going to schedule it for the entire class, I guess. Correct?
Yes, sir.
Okay. I will do that. I will do that. Okay, let's end this meeting now. Thank you. See you in 10 minutes.